sum of 4 values. In this problem, we are given with the array of n integers and our task is to find 4 values at different position whose sum is x. We need to print 4 integers, the position of the values, and not the values itself. We need to print the position. So basically this problem is building upon the sum of 3 values. So I would suggest you to watch it first. I will link it down in the description. If there are several solutions, we can print any one of them, and if there is no solution, we need to print impossible. So let's say we are given with 4 in values and some target. Then what we were doing some sorting mechanism, and we were adding one light and one heavy number, and this we were doing in two sum. In three sum, we locked the number, and we were having two pointers, front and rear. Also, this locking number doesn't mean that we are locking it forever. It is just a way that we are implementing two sum in this section while locking this. This was done in the sum of three values. Now in sum of four values, we will having two locking indexes. So we will lock these indexes and again apply the two sum in this section. Let us see this all with an example. We are given with this array of 7 values and some target 20. We have done the sorting, and also I'm not showing the position here, but the logic for maintaining the position intact with the array of numbers remains the same what we were doing in the sum of three values. So I'm not explaining it here. So we have the array of integers which are sorted, and we have locked the index 0 and lock the index 1. This is so because we will lock those two indexes and apply two sum in this now. So we have the front pointer which is pointing at index number 3. Now what would be the sum of this? Will be sum of this will be locking index 0 wherever it is pointing, this plus this plus this plus the rear pointing which was 8. So this will come out to be 50, which is still less than the target. What we used to do in the two sum, we increase the front pointer because we want to increase the heaviness of the sum. So we will increase. Now here again the sum would be 16, right? 1 plus 2 plus 5 plus 8, which is still less than 20. So we will increase. Again it is less. This would be 17. We will increase. Now 1 plus 2 plus 7 plus 8, again less, which is 18. So again we will increase. Now we have come where the front and rear is pointing at the same position, and we know it is clear in the question we need to print the position at different, not so front and rear are pointing same, so we won't consider. That means we will unlock the index 1 and we will increase the index to basically 2, right? And again apply the two sum in this section. So we can, it is quite clear, right? What we were doing in the three sum, we are doing almost the same, just we have instead of one locking index we have two locking index. Again front will be pointing here, so 1 plus 4 plus 5 plus 8, that would come to 18. Again less, so 1 plus 2 1 plus 4, right? 1 plus 4 plus 6 plus 8, this will result in 19. Again less, so we will increase. So 1 plus 4 plus 7 plus 8, that is 20, right? So sum is equal to target. That means we have found one solution. So we will display it. And we know the other condition also, when sum is greater than the target. So we decrease the rear. Also, when this locking index will move to the end position, that means with this combination we didn't found any solution. So that means at that time we will unlock this and will move this locking index 0 to this position, and this would be plus 1, right? So the second lock will be starting from here. Again the same we will apply to sum now in that scenario. Okay, so here we are with the some snippet. So we have the index 0, which is the first lock, and this is the second lock, which I told you it should in be by 1, increase by 1 wherever the first locking index is, it should be pointing next to it. And then this is simply we will get the first number value wherever the locking index is pointing, we will get. Similarly for the locking number 2, locking index 2, wherever is pointing, we will get the value, and now front will be pointing locking index plus 1, right, as shown in the diagram. Rear will be the size minus 1, and what with the sum would be wherever these two guy are pointing, that would be sum. And now we will apply with these condition are 2. So let's write the code of it and we will have a better picture. So first input will contain two integers, n the size, array size, and the x is the target, and the second line will be having the array values, and we need to print four integers, the position of the values whose sum is going to become the target. So I have written some code. So basically this is the input, we have the size and target, we get the input, we push this in a container, and our container is nothing but a vector which consists of pair. So basically the first position would be the value itself and the second would be the input. Then we have done the sorting. By default it will sort based on the first value, which is input. Once the sorting is done, we have these indexes, these locking indexes, and now we need to grab the locked number value. So basically this is the value, and we can get by wherever the container locking index is pointing dot first, right, because first in the pair the first position contains the value and the second contains the position itself. Similarly, we will be having for locked number 2 the locking index wherever 2 is pointing. Then we need to pass this all in our toSum. So toSum contains front will be wherever the locked number is, actually not locked number but the lock index wherever is locking index, that is locking index 2 wherever it is plus 1. Rear will be size minus 1. Then we need to have a sum also. So sum would be basically locked number 1 and lock number 2, because this would be the initial sum, right? So I think I have not defined sum, so let us just write int sum equal to 0. So now we will call our toSum function. So I think it has not been defined, so let us define. So we will pass front, rear, sum, size, the container itself because it contains the value, and the target. So let's define our toSum over here. So basically it has all the this is the function signature of it, and the container is passed by the address. So toSum, so what we used to do in the toSum, so basically we need to go until the front is less than rear, right, because we want different position. Then the condition was if sum is less than, if the summation is less than target value, we were increasing our front. If it is greater than the target value, we were decreasing the rear, and at the end sum becomes equal to target value, we were displaying the position, right? So we need to also form the sum here. So let's define sum equals 0, and sum will be container front wherever it is pointing dot first, right, because now this is where the front and rear container wherever it is pointing, we will have this. And also I need to make the sum equal to s, right? Why this? Because this was the sum which we got from here, and that sum was containing wherever these locking indexes were pointing, lock number 2, lock number 1. So now the sum will become this s, right? And in that sum we are going to add the wherever the front and rear is pointing, right? And now listen very carefully, when we add and sum becomes, let's say, less than the target value, we will increase our front, right? And neither of this is going to execute. Now since sum is less than the target value, front is going to increase, and again we will go back and we will again start from here. So sum will again become the s, right, the wherever the locking indexes was pointing, and in that again we will increase. Now we will add now wherever this new front is pointing. So that's what this condition is doing. It is recomputing the sum back to original so that it doesn't kill the algorithm. So now if sum becomes the target value, we will simply display wherever front is pointing, it's the position, right? We need to display the position, and wherever Where is pointing its position, right? So, and also since it has to return something, I will return 1. That means we have found one solution. And in other cases we can simply return -1. That means we found nothing. Now we can take this in a result variable. So let's define a result also, and result equal to dosum. Now if result is equal 1, that means we have found one solution. So right, we can simply display. What we need to display? Container locking index wherever it is dot second, because this is where it contains the position, and simply container locking index 2 dot second, and we can return from this function. In other cases, if this was executed but we were unable to get any answer, we can simply display impossible. Okay, so now let's try to submit this and see. Submit. Okay, so it has been accepted. So basically this was built upon sum of two values. We were having just one for loop to lock the index. Now in this scenario we have another index also. So you can see now we can keep on going and make 4 5 sum, 6 sum, 7 sum, right, by just adding the for loops. And of course this is going to increase the time complexity. This time complexity is going to increase by the addition of these for loops.